Thanks for everyone who's joined so far. I've hosted this last week, and this is our second week, and we're going to do it every week now, just to keep the community interacting during these tough times. I know everyone's sort of scratching about, and it's good to keep everyone updated with what's going on in the market. Oliver Bernards have actually set up a Just Giving page, which I'll attach to this event and to all our events going forward to help donate to the vulnerable during this time. So I'll pass that across to you. So doing the talk today is Michele, who I'll pass you across to in a sec. He is the co-founder of Candu Labs, which is a React in-app learning platform. And obviously he'll be talking through the topic of scaling and building in Scala. So I'll pass you across now. Also as well, this is recorded, so what we normally do is get a media company to help edit it, obviously the good and the bad bits. And all the questions I'll ask at the end. So anyone who has a question, there's actually a button to raise your hand, and then I'll actually put the video onto you, and then you can ask Michele a question directly. But I'll pass you over to Michele.
Cool, thank you for the intro, James. I cannot wait to see the video from the media company of my bedroom. It's gonna look fantastic. But yeah, let's dive right into it. All right, so we will be talking about how we build infrastructure as a product here at Candu. So what we will cover is, first we'll talk a little bit about us, then about the underlying principle of how we think about infrastructure. So mostly about the trade-off that we think about building infrastructure as a product and infrastructure as a service, and I'll explain what those are. And finally, we will cover a couple examples of two products, Hammock and Convoy, that we have built inside Candu. And if somebody's interested in questions, I can also explain a little bit more about Fleet, which is a similar service, but for front-end developments. Wonderful. So let's dive right in. So first of all, we are Candu. As we mentioned, we are basically Squarespace for our app. Our mission is to leave no customers behind. We work with some of the best software as a service companies to enable them to build better product experiences for their customers inside their application. So it's a complex product that we're building both on the front end and on the back end. We do lots of analytics. We do lots of very complex, really complex work. And so we're very excited about the infrastructure that we have built because it really enables us to move really well. So far, this is our team. We are still hiring. We are a remote first company. Oh, I see there is one chat. Let's see. Cool. We are a remote first company. Sorry. But we do have an office here in London. So I wanted to talk a little bit about our requirements in terms of Candu as a company. So first of all, I shall say we are definitely a pre-product market fit company, which is why we need to move quickly. So a lot of the things that we have built in terms of infrastructure so far are fairly minimal. But they're basically structured in a way that enables us to then scale it. It enables us to easily, move at a much faster pace in the future without having, huge technical debt. The other part is that we actually sell to enterprise companies. We sell to companies, like Beamery, like Launch Darkly, Amplitude, large customers that have they want us to have high availability, because how we create our software impacts the customers. If we are down, their experience will be impacted right away. And finally, we also have an analytics platform and data ingestion from these customers. So we need to be able to handle large loads onto our platform. A little bit about our stack. As we mentioned, we are a Scala shop. We are built on top of the Play framework, which I've been using since 2012, and I absolutely love. On the front end, we use React, Redux, Webpack, and some of the usual suspects. In terms of data, we have Postgres as our relational database. We also use it for some of our analytics through a real-time streaming pipeline. We use Elasticsearch for some other analytics, and S3 for actually storing some of the customer data for high availability purpose, and coupled with that we also, those are mostly static files, so we can actually store them. In terms of infrastructure, we are on AWS shop, so everything is deployed on AWS. Cool. So infrastructure is a product. What does this mean? So the core principle, the core way that we think about building infrastructure as a product is that instead of running services, our infrastructure team is concerned with creating products. So we really believe, in Candu, we really believe in engineering driving product. And that also extends to infrastructure team, right? So what we think leverages them the best is actually to understand what's needed to run the platform and create products that can provide those services. And the reason we do this is that we are lazy, because ultimately we want to be building these products instead of actually handling one-off requests about spinning up a machine, rolling back a certain service, or all these classic DevOps tasks that exist. We basically want to be able to automate all of these. And then because we have ways to automate, because we have a platform, we can, iterate quickly, we can provide high availability, and we can overall move very fast. So the way that we think about building these products is essentially, these are very engineering-driven products, of course. So the things that are key in that we have seen is, first of all, defining a service contract with product teams. So when you think about creating a product for a certain part of your infrastructure, you have to think, what are the guarantees that you want to do, that you want to provide? What are some of the essential components that, what are some of the contracts that the product team need to respect, right? So these are mostly boundaries, right? Think of it, you are restricting the possibilities of what they can do with their product in order to greatly enlarge their productivity and what you overall as a company can do, right? And that's what we mean by defining a service contract. And finally, you need to implement, we implement an MVP of that contract, of that platform, to provide that service that we originally wanted. And we then get feedback on it and iterate and scale it as needed. So in classic infra teams, this is what it looks like, right? You have an infrastructure team, and you have product teams, and a product team would need, normally ask for a service to be run to the infra team. Infra provide, provisions a certain environment, and then the infra team runs directly, right? Now, we still do that in certain cases, right? So, for example, for Elasticsearch, we simply provision that through Amazon, and we run it, right? We do run it using the AWS managed service. So we effectively, Amazon does this for us, right? They offer the infrastructure as a product. But for many other products, and we will explain some of those, we actually create infrastructure product that we can run ourselves. And the advantage of this is the added layer of abstraction. So we have one more layer of interaction that enables us to decouple the contract that we have given to the product team to the actual implementation. And that's really what enables us in the long run to move very quickly on some of these services that we build. So because we have this added layer of, because we have that added layer of abstraction, right? This overall can enable us to, do lots of work under the hood that product teams don't see, and that really enable us to offer a really great development experience and offer a really great customer experience. So the advantages of doing, some of the advantage of infrastructure as a service in places that we use is that overall this is just simpler, both in terms of like the technology, right? You're just provisioning a service and that's it. But it's also much easier in terms of team organization, right? I have often seen large companies falling back to this model, not because of the technological barrier in implementing these things, but because it's very difficult to build consensus around product teams around what the consent should be around these services, right? That's one of the key challenges that I really see in infrastructure as a product. Is often very, very difficult to build these products internally when you have to put, when you need to have all these teams agreeing on what those products are. If it's greenfield, is much easier, but if you have legacy infrastructure, it can be very difficult to do that. Some of the drawbacks is that infrastructure as a service doesn't necessarily scale well, right? If you have tons of services to manage, this, it can become very difficult because you basically have all these one-off services that you need to go ahead and manage, and you need to provide, monitoring, logging, versioning, and security onto all these services. You also tend to suffer from vendor lock-in because you don't have that layer of abstraction. You're normally using, infrastructure directly, and you tend to run these things ad hoc because it's very difficult to run them directly. Instead, when you build things using the infrastructure as a product service, you have a much higher, initial investment, and it can be difficult to implement across team, like I was saying. So let's look into a couple examples of some of these products that we have built at Candu for, just to give you guys an idea of what we're building. So the first one is called Hammock. Is a lightweight REST framework that we use to power every single one of our REST APIs. And yes, it is built on top of Play, so there will be some Scala involved right now in the code. So the reason, the real benefit of Hammock is that it simply standardized the way that we build and APIs, right? So no matter the team, no matter what you're doing, the contract that our API, our API contracts look exactly the same for all of our APIs, right? Which gives us a lot of advantage in terms of productivity, right? It really makes it super productive for development teams to write APIs, both for backend developers and for front-end developers. Is kind of one way to think about this is a very, very simplified version of GraphQL. So it's like a resource-based way to think about REST. This has been inspired by Restly and Naptime, and in particular Naptime, which was the framework that we use at Coursera, is a very, very simplified version of this, basically. And some of the things that is really cool that is it abstracts a lot of things from developers, right? So this is again where you can see that approach to building, infrastructure. This is where all the benefit of that interaction, all the benefits of that abstraction come from. And because you have this layer of abstraction, this makes it very easy to iterate, for the infra team to iterate in the future, right? So just to give you an example, right now we are built on ECS because it's very simple and used. But if we need to shift to Kubernetes, we don't need to modify any of the ways that we build products because this is fully abstracted from product teams, right? They don't need to know about that. And so that gives us the flexibility to move very quickly with very minimal setup, but make it so that we can rewrite it in the future, make it so that we can scale it quickly in the future. Cool. So I want to talk a little bit about, when I describe Hammock, a lot of people are like, oh, but why didn't you just use something else? Why do you have to write another framework? And overall, this is the core of Hammock in our Scala code base is only 1,500 lines of code. It's pretty simple because it just leverages the play framework. It basically just kind of, forces the play to it just narrows the number of things that you can do in play to actually give you a lot more power overall. We couldn't use GraphQL alone. We couldn't only use GraphQL because we needed a REST endpoint for a variety of reasons, and because other similar frameworks that we looked into had a pretty steep learning curve, had a pretty steep setup that we didn't really want to pay. Cool. So let me walk you through one example of how an API with Hammock looks like. So you can define your models. For those who are not as familiar with Scala, what this does is defines, a user ID, which will look something like, when serialized to JSON, it will look something like ID 1. And, we have several code that enables us to format things, however we want. And user ID, again, this is the model. So the way that Hammock works is basically you define a key that you will use to access your resource, and then you define your model for the resource, in this case, user. And here you define the API name that you're going to access. One second, let me change slide. Cool. So in this case, you are accessing user ID, and you will be able, you will once this is doing is implementing a GET request for a single user ID, and you can see here how simple it is to actually write infrastructure in this way, right? So we have a REST action that defines a GET method. The GET method has a signature of user ID to option of user ID, and this basically and then Hammock will basically execute this request, and it will output a 200 with the body of this request if we have found it. So in this case, some user ID, we have found it, so it will output the email. And it will return a not found if this is none. So again, you can see here Hammock actually abstracts all the HTTP, extracts all that communication from whoever uses it, so that you can really just focus on building APIs, right? And this is actually where I really like to think about infrastructure as a product, because this is not something that would necessarily enter in the infrastructure realm, or at least in the classic definition of the DevOps realm. But because of that, of the way that we think about, overall building infrastructure to solve developer building infrastructure to solve developer problems, these type of things actually, actually are a way to improve developer productivity. Let me clear my annotation. Cool. So as we have implemented this, we have seen that this has really improved our developer productivity, both for backend and front-end developers. So on the front end, we actually have, we also standardized, because the way that our resources are formatted is very consistent. We also have a very small, a small client that enables us to do mutation, to access all this data. Again, somehow similar to what an Apollo client would look like, just only built for Hammock. And again, the reason we do this is that we also on the front end want to provide that level of abstraction, so that in the future, if we want to shift to GraphQL, if we want to use Apollo, the transition will be very simple. Let me clear annotations again. Cool. Now let's jump on to our second example of infrastructure products that we built at Candu. And after this, I'd love to get some questions on how we build products. So Convoy is a way that we use to build microservices and deployments. One way to think about it is a very, very, very user-friendly version of Kubernetes. Well, or actually, it sits on top of Kubernetes or ECS or whatever you're using for this type of things. Again, what we're really interested here is providing that layer of abstraction, so that this becomes very easy for our developers, for our product developers, to use these really complex technologies, and it gives us the flexibility to iterate very quickly on the actual infrastructure and on how actually our services are run without necessarily running in any lock-in, right? So we don't have to use Kubernetes, we don't have to use ECS. For now, we use either one, doesn't really matter. In the future, we can change it. Oh, sorry. Cool. So the way that Convoy works, is, actually, I think I skipped one slide. For some reason, it's not really changing slides very well. Okay. So the contract that we have in Convoy is that services need to be stateless. So you cannot build any stateful service. You must have some level of service configuration in terms of how you want to run that service. And we also only support services in our Scala monorepo. Monorepo is very key here. You will understand very soon why. And what Convoy provides to our developers is we have automated deployments. So if you put Convoy in automatic mode, it will automatically deploy every time we merge master. This is the default mode of how it is most of the time, because we love automatic deployments. We love just being able to merge and actually not having to spend time, looking after the deployments and stuff. However, if you need, you can also do blue-green deployments, which means you spin up a cluster, you wait, you slowly shift traffic to the other cluster, and you wait to see how well that cluster is working. We also have production and staging environments provided through Convoy. And finally, Convoy provides login and monitoring. So if there are problems with the deployments, if there are problems in our infrastructure, again, developers don't have to think about any of that. Is all automated for them. Cool. So let's look at how Convoy works. So we have our source code here. For any branch, we have a monorepo setup. We actually force rebase and squash commits in our code base. So we have a linear tree history, so very clean. We have very strong merge, master protection rules. This is part of the contract on the way that we build all this infrastructure. So that basically each commit ID, what those restrictions enable us to do is that you have unique, the commit hash ID, which because of those restrictions is immutable, is a unique ID across all of our code base, across all of our infrastructure, to identify any development, any deployment that you have. So every time you merge a commit in master, in any development branch, we use AWS commit to build a Docker image. So we build a Docker image of any one of all of our services, right? So we have a monorepo. The monorepo contains all these different services. We construct, we build a Docker image of that monorepo, and then according to the configuration that you run the services, it will run it will run all the different services. And inside the ECR registry, we keep a version of every single commit that you ever did to our code base, right? So once we do that, we then use the admin panel to basically orchestrate the deployment of these services onto ECS and onto Elastic Load Balancing, right? So let's say, for example, I merge in a commit into a development branch. GitHub gets a commit, it kicks off a build. the build deploys a Docker version, and through Convoy, I can deploy that onto ECS cluster. Doesn't matter, ECS, whatever technology you like to use to run Docker, and then the Convoy service will actually build, will actually modify the target group, will modify the AWS infrastructure to register those target groups and actually listen to, and actually build that deployment in production. So we have support for different environments. So we have one for production and one for staging, which have slightly different rules. I will say one thing that is really nice is about building services on top of AWS is that it's very, very easy to use the AWS client to build all of these services, which is one thing that is super nice about using the JVM. Cool. So here you can see an example of our internal panel. Here you can see all the deployments that we have done. These are all the builds. And you can see how quickly you can just stage an API and actually test the service. The way that then this will actually work is that it puts a certain cookie onto the load balancer so that only if you have that cookie, you can actually access that service. And so what that enables us to do is that you can have a really, really good staging environment in production very easily. And sorry, once again, let me clear all my annotations. Great. Again, we leverage AWS and load balancing for service requests. Yeah, I've already described to some of this way. We also use auto scaling to really enable us to handle this load, and CloudWatch for all the monitoring and logging. Again, what I really want to stress here is that in this mode of building products, it doesn't really matter which solution we use here. These are all solutions that work very well for us now, but because we have that layer, a very well-defined layer of abstraction, we can very easily change these in the future. Doesn't matter. We want to have something that's, much more bulletproof. Sure, we can do that very easily. We can identify the problem, and we can iterate over this infrastructure very quickly because we have that indirection layer. Cool. Right. That's all for today for me. I hope that you enjoy some of the inner working of the way that we build infrastructure. We actually have a similar way that we build our front-end services that's similar to the way that Convoy works, but just for actual front-end production assets. If you want to hear more about that or about anything else here at Candu, I'm happy to stick around, for as long as I can to answer any question that you may have. And yeah, thank you very much for listening.
Perfect, Michele. That was really interesting. Thank you very much. So what I'll do is, if everyone, I'm sure people have got questions for Michele, so I'll open the chat panel up now to questions. Whoever actually does have a question, I'll make sure you can speak over video. We just find it a bit more interactive rather than me asking Michele questions, sound like a robot. I'll also, after this event, I'll post Michele's email address on the forum as well. So if you want to ask him any questions directly or anything about Candu, I'm sure he'll be happy to answer. So the first question, I'll just pass you over and ask him directly. So he said, is it possible to add Swagger UI to Hammock?
Yes, actually it is. It's one of the things that I've looked into because I think it would be a very nice developer product to have the Swagger UI. The way that it would work is that we use macros to parse the, to basically parse Scala, to parse the Scala case classes. And yeah, absolutely, it's possible. We haven't done it yet simply because our team is still fairly small. So it's not that difficult for them to just go into the actual code base and look at the classes. But there are several good use cases for us to do that. So it's something that we might want to do in the future. The other thing that is really cool that we can do in a similar style to have like auto-generated documentation is to actually build the TypeScript definition from the models that we use in Scala. So from the models that we use in Hammock. I'm really excited about that one.
Thanks, Michele. I think there is a few more questions, but I think I'll have to ask you directly because it looks like we can't open the video up. But I'll pass all the questions and answers on in the group as well. And again, if anyone's got any questions about the market, either email myself or Michele. Obviously, these events are to help obviously build companies' profiles and get it out there. So Candu actually hiring, as Michele mentioned. So if you're looking for a new role, please reach out to him and myself, and we'll speak to you. And I hope everyone enjoys. And as I said, we've got this all recorded, so we should have the full edited version finished by tomorrow, and then I'll get it sent out. We're actually going to start a YouTube channel as well, so we can get this.
We've got another question.
We do, yeah. Hi, Roger. I'll try and open this up to you as well. Second time lucky. Hopefully it might work.
Yeah, I was just wondering if you in your stack you use AWS Fargate or any of the CloudFormation type stuff.
Yeah, so we don't actually use Fargate. We use the EC2 mode in ECS.
Okay.
The reason for it is that I don't really understand how, to be honest, I don't really understand how Fargate works. But I understand how the normal mode works, which is you just spin up EC2 machines and then you put auto-scaling on it, which to me sounds pretty straightforward. So I don't really, so I've done a little bit more research on it, and I basically heard that the Fargate provides a slightly better another layer of abstraction, but from the people that I talked to, who know a lot more about AWS and EC2 than me, ECS, they all mentioned that it wasn't really worth it. And to be honest, like with the plain mode in ECS, it's worked really well for us. And the auto scaling on the EC2 machines is really, really nice. So I think as long as you're not scared of setting the right memory limits on the Docker machines and stuff, like the normal mode on EC2 has worked very well for us.
Okay, and the follow-up was have you used any CloudFormation type scripts?
Yeah. We don't use CloudFormation. We do use Terraform to define some of these. So, for example, the EC2 ECS cluster that we use for Convoy, or the clusters we have, the staging and the production ones, are created using Terraform.
Okay. Yeah, I was just thinking, we've used Fargate before. It's kind of their Kubernetes kind of solution. I don't know, it seemed to kind of fit with what you were saying.
Yeah, I think, it's a matter of implementation in this case. I think is we could switch to Fargate very easily if we find that to fit our needs better. It would basically just require us to change some of the logic that we use to launch services inside the Convoy, inside the APIs that we use to orchestrate. So we could do that very easily. And again, that's kind of the benefit that I was talking about in, abstracting all these things, is that they really provide you a lot of flexibility in terms of experimenting and in terms of trying different things.
Cheers, Roger. I think that's it for now. Obviously, any questions we'll add on. But thanks for your time, Michele. That was really helpful and really interesting. I hope everyone enjoyed it. We, as I said, we are actually looking to run this every week. So if anyone wants to speak or would like to speak about their company, please reach out. And I'll get this all edited and put on the meetup page tomorrow. Perfect. Well, thanks everyone. Have a nice evening. And
thank you, James.
See you later. Take care. Bye-bye.